Okay, so we talked about descriptive data analysis when looking at univariate statistics. So for this section, we're going to focus on bivariate and multivariate statistics and talk about what those mean. Bivariate focuses primarily on relationships between two variables. Multivariate tests and statistics look at the relationship between three and more variables. So let's dive in and see what that looks like. So bivariate analysis, what we're actually doing is not just analyzing one variable. Now we're starting to look between two variables. We want to see what are those relationships. These tend to be a little bit more explanatory. Univariate analysis is just saying how often something occurs and the numbers related to that. Bivariate is saying, is there a relationship between these two variables? So let's say we're looking at a group of individuals and we want to see, hey, are individuals who identify as female, as moms, more likely to have attended parenting classes than males? And so let's say we administer a very quick survey. Yes or no, have you ever attended parenting classes? And so what we can do is we can create a frequency table that shows the frequency that people responded and then the percentage. So you can see on the left, males maybe said, one male said, yes, I have. 8 said no. And so 1 is 11% of our sample, 8 is 89%. 3 women said yes, 8 said no, making 11. You can see percentages, 27 and 73. And then at the bottom, you get the total, which is 20% of our sample, or 4 people, said they had attended parenting classes. 80%, or 16 people, had said they hadn't, coming up with 100%. So what can we assume from this? Well, we could say, it looks like parenting classes aren't super popular. The majority, 80% of our sample, had never attended a parenting class. And while women were slightly more likely to have attended, it wasn't a huge difference. And normally there could be some tests you could run to say, is that a statistically significant difference between them? But let's say it's a slightly different sample. Let's say we administer it to a different group of people. Only 1 male says yes, but 7 of the females, so 64% of the women who identify as female, say, yes, I've attended parenting classes. What we could look at and see is, say, 40% of our sample had attended parenting classes, but the majority of them were female. And then we can look at 60% and say, okay, well, yeah, a little over half had not attended parenting classes, but there's a discrepancy between those who identify as male and those who identify as female. So these bivariate tables can really provide a lot of insight just looking at them, just eyeballing. Now, there's a test called the Chi test that you can actually use to come up with significance of these boxes, but the book only really talks about these types of frequency tables and the information that it can provide. With multivariate analysis, we're now looking at relationships between multiple variables, like one independent variable and multiple dependent variables, or multiple independent variables and 1 or 2 dependent variables. Sometimes you can have tests that are literally like 3 independent variables and 4 dependent variables. It tends to be more explanatory. So let's say I look and I'm like, you know what? Not only is my hypothesis that I think that women probably are more likely to attend a parenting class, but I think there's an age issue here too. I actually just read a study before I created this presentation that found that in the older generation, which they identified as the boomer generation, even though I know that's not a great term, 43% of fathers had never changed a diaper. But if you look at millennials, only 3% had never changed. And they were talking about the changes between generations in the role in fatherhood. So maybe I look and I say, I want to see, does age also have an effect on likelihood of attending parenting classes? Not just are you identifying as male or female, but what about age as well? So what I could do in multivariate analysis is break up my table like this. And what you could see is maybe in the 20 to 40-year-old range, they're pretty even. 6 males and 7 females have attended parenting. 5 males and 5 females said no. So it's pretty evenly split between yes and no and male and female. But maybe I separate out my 41 to 60-year-olds. I want to see if there's that generational difference. And maybe what I find is the majority of males have not attended, right? 9 versus 1, only 1 person in that age range attended a parenting class, but 9 females had. And so what I could say is when you look at age, older age, you can say that it looks like men were less likely to attend a parenting class. So there was a difference between the ages and a difference between the genders only in 41 to 60-year-olds. So hopefully that makes sense. There's a lot of really interesting tests that you can use, but this again is that visual to say, okay, if I look at my numbers on the very right, half my sample has attended parenting classes, half has not. But when you break it down by age, you see a much stronger discrepancy between yes and no based on gender in older individuals than you do in younger parents. So some things to think about to at least give you an idea of looking at multiple variables variables and using a table to be able to explain a relationship a little bit better. A few more things to talk about. The book also references correlation coefficients. So a correlation is testing that strength of association between two variables where one is ordinal or continuous. And so we talked about this several chapters ago when we talked about positive correlations where both variables are increasing. Negative is where one is increasing and one is decreasing. And we're going to say a correlation is between -1 and 0 or 0 and 1. A -1 is a perfect negative correlation. A 1 is a perfect positive correlation. And you can see in the table, typically we have some ideas that if you have a correlation that's 0.7 to 1.0 or -0.7 to -1.0, you have a very high correlation, very strong relationship. Or if you have 0.5 to 0.7 or -0.5 to -0.7, moderate. Low is 0.3 to 0.5, and 0 to 0.3 is a negligible correlation. We might say, I don't even think there is a relationship between these two variables. Now, correlations are interesting because they don't assume an independent variable or dependent variable. They just say, hey, we've got two variables. We want to see if there's a relationship between them. If you do have an independent and dependent variable, we have other types of tests, linear regressions or ANOVA, which is looking at differences in groups. But in this case, you just want to say, is there a relationship between these two things? I think the previous example we talked about was age and cognitive score was a negative correlation, or we looked at number of falls in age as a positive correlation. There's a couple tests. Pearson's R is a very common one. You have to have an even distribution, and both variables have to be a number of some sort. Spearman Row is when one variable is a category, like yes or no, male or female, and then the other one is a number and it's non-parametric. So you don't have to know all this. Just know that there's different types of correlations depending on the distribution of your data. So here's an example or a visual. Let's say I want to look at the number of absences related to an individual's GPA. So this would be a negative correlation because the more absences you have, 16 or more absences in a semester, the lower your GPA might be. So as your absences go up, your GPA goes down. So this is a negative correlation. And we want to see, is there a weak, moderate, or strong relationship between absences and GPA? Well, what you could do is you could run a correlation test. And this is a pseudo one that I did in SPSS based off my fake GPA study. And what you see is if you look at Pearson correlation and absences, you see negative 0.986. It's negative because it's a negative correlation. And remember, I said if it's 0.70 or higher, that's really high. Negative 0.986 is a very strong correlation between number of absences and GPA in this fake study. And there's a significance level that's less than 0.05. And so we'll talk a little bit about that in the next chapter. But basically it's saying this is a very significant correlation. We can say pretty firmly there is a very strong relationship between the number of absences a student has and their GPA. Now, we're not saying the GPA causes the absences or the absences cause the GPA, right? But we can say there's a very strong relationship between the two. Finally, the book wraps up this chapter talking about effect size. So this is looking at assessing whether an intervention had a strong effect on the changes in the dependent variable. So for example, we have two interventions, let's say to improve parenting, intervention A and intervention B. We use a pretest and a post-test to measure the number of positive parenting behaviors noted in a 1-hour session. Let's say for intervention A, there are only 2 noted on the pretest. Those who participated in intervention B, the 2 groups, the average was 9 on the pretest, positive parenting behaviors. Let's do a post-test after the parents complete intervention A. So they had 2 positive parenting behaviors in an hour on the pretest. Well, they jump up to 10 on the post-test. Let's say in intervention B, they averaged about 9 positive parenting behaviors in an hour. And by the post-test, we ended up with 12. And so what you might say is, oh, well, look, people in intervention B, they had a higher number of positive parenting behaviors. But if you look, the jump from the pretest to post-test in intervention A is pretty significant, right? 8, they literally 5 times more positive parenting behaviors versus intervention B, it was only a slightly higher percent. And so typically when you would look at an effect size, you would see a stronger effect size for intervention A. Yes, they don't have the highest outcome, but man, there was a pretty significant effect of the intervention on their post-test score compared it wasn't as strong in intervention B. And so effect sizes are really important as well when you're looking at interventions, when you're doing a literature review to say, okay, so they're showing that I had 2 groups, one was treatment as usual and the other wasn't. They had a new intervention, but man, the effect size for the new intervention isn't very strong. It looks like it maybe could be other factors, not necessarily the intervention itself. So it's really important to understand effect size as well. So let's tie it all together right at the very end. So this is a really cool study looking at different facets of social connectedness in students in discussion groups. And so don't worry about that T32 yet. We'll talk about that later. But what you can see is, as indicated in Table 1, students rated sociability higher for the small group discussions. We can see mean. The mean was 4.05, and the SD, the standard deviation, was 0.74. So they rated it higher than large groups. So people in large groups, the mean score was only 3.65, and the standard deviation was 0.92. So what this means is those in small groups had slightly higher average, and their standard deviation was narrower. They were closer around the average. Maybe they were a little bit higher in general, and you didn't have as many outliers. Those in large groups had a more moderate mean and a larger standard deviation, meaning some of them really didn't agree and some of them super agreed. So that's how we read that. And they said the effect size, like I just talked about, was sizable. They used Cohen's d, which is a very common measure of effect size, and it's 0.61. And so that means that it had a pretty strong effect. They can say that small group versus large group, that variable, appeared to have a pretty strong effect on their mean score and standard deviation. So how they concluded is they said this result supported our hypothesis. Students perceived that small discussion groups facilitated higher levels of social interaction. So hopefully that gives you an idea when you're reading your research what all the abbreviations mean. M is mean, standard deviation is SD, Cohen's d is effect size. So hopefully that was helpful. Here are my references.